So we're looking at the cyclist problem, and we've got that the first cyclist travels 25 kilometres per hour plus 50 kilometres, and we have the second cyclist who's travelling at negative 25 kilometres per hour and starts 300 kilometres away. So you've done a graphical version, which is fine, but sometimes it's a lot easier with these to actually do it algebraically. Our question says find the time when the two cyclists are the same distance from home. So what we're trying to find is when is this first distance equal to this second distance? You know, we want these two things to be the same. So we use this kind of cool thing. I call it Equate the Equations. It doesn't have a real name, that's just my made up version. If we know that this is going to equal this, right? And we know that this first distance is equal to that, and we want this first distance to equal to this second distance, and this second distance equals this, we can just take this first equation and join it up to this second equation. So I'll write down what I mean. So this first equation, 25t plus 50, needs to be of some kind of value, which is the same as this value. And this value can be found by using this equation. So I can just say it's equal to negative 25t plus 300. So now I need to use my solving algebra skills to find this out. This is a situation where we've got pro-numerals on both sides, right? We want to eventually have the t's on one side of the equation and all the numbers on the other side. So probably start with the lowest t, so negative 25t, and we're going to do the opposite to it. So we're going to add 25t. So I'm going to write that little. We're going to add 25t to both sides. Negative 25 and positive 25 make 0t. Okay, so I've got 25t plus 25t, which is 50t, plus 50 equals, remember this was 0, plus 300. Okay, so now we've got the t on one side of the equation. All right, so now we want to get rid of the numbers. So we're going to use our solving equations. We're going to take away this 50 from both sides. That leaves me with 50t equal to 300 take 50, which is 250. We're nearly there. We want to get t by itself. It's being multiplied by 50, so we're going to divide it by 50, which means we have to divide this side. So then I've got, cancel that, t equals 250 divided by 50, which is 5. So what that's saying is that the time it will be when the two distances are the same is 5 hours. So therefore, 5 hours. The question is, what distance is that? Well, the easiest way to find that out is we take our answer for t, okay, and we substitute it into either one of the equations, right? I tend to do the one that's got lower numbers. So take that t and substitute in. So d1 is equal to 25 times 5 plus 50. So 25 times 5 is 125, plus 50 is 175. So the distance that both cyclists is 175 kilometres. If I wanted to check that that was correct for the other one, I could just substitute it into the other equation as well. So I'll just do that to prove it to you. So let's substitute these 5 hours into the second version. So negative 25 times 5 plus 300. Negative 25 times 5 is negative 125 plus 300 is also 175 kilometres. So the answer to this problem, or the solution to this problem, is at 5 hours, the distance both cyclists are from home is 175 kilometres.